Hey, welcome back. This time we are going to work on simulating a population growth model that works for any population growth function. So to look at where we started and where we're going, I figured it would be good to have an example written out about what we had done before for our constant growth model. So back in chapter 5, all the steps that we needed to create our simulation of the results was set up in this way. First we calculated t0, t end, p0, p end, the annual growth rate. When we had the annual growth rate, then we could start to actually run the recursion, run this inductive step. So we needed to define our initial value of the population. We needed to then run this for loop to be able to calculate the results at time t based on the results at time t plus 1 as a function of the results at t. And then we would visualize that information here at the bottom. Um, this is what worked for the constant growth model. What do we want to do in order to take this and make it work for any growth model? All right, so I'm going to break this down into 3 different parts. First part, the second part, and I'm going to put in one more thing right here. All right, so first thing I want us to do is we want a simulation that takes these pieces, this T naught, P naught, the annual growth. Those are parameters that are part of the system that the system needs to work. Let's take those out and let's create an object that will keep track of this bag of variables. So the first part is we need our bag of variables. This time, because these are parameters that the whole system needs, we're going to call this a system object. So this is going to be a system object, and it's going to have our bag of variables. These are going to have the system parameters. And so we'll talk about these system parameters for each of the models later on. We've actually already seen them, but we want to keep a bag of system parameters, and that's going to be the first part of what we need. So let me put this in yellow. So what do we want? So we need a system object. And again, this is just like in state, we had capital letter. Here we have a system object with system parameters. And this is a model-dependent thing. All right. The next thing that I want to highlight is this green part. So if you look at the way we ran our simulation, the constant growth model had this as its rule for getting from time t plus 1, from time t to time t plus 1. So what we're going to need is we're going to need a function that gets us from time t to time t plus 1. So we need a growth function that calculates the net growth of the population from time t to time t plus 1. Right? Again, this is model dependent. So each growth model is going to have a different function for calculating the net growth. But once we strip out those system parameters and once we strip out that model-dependent growth function, then all that's left is just always the same. So the last thing we need is we need a run simulation function that takes in the system object and it takes in the growth function. It uses that information. Oops, I'm in the way. It takes that information, loops and generates all the data, runs a loop to generate the data that we want, simulated data, and then outputs the results of the simulation. Right, and this is going to be this red part of the simulation. We need this one thing. It doesn't matter what the growth function is. It doesn't matter what the system parameters are. This red part is always going to be the same. So let's define it. So let's define this red part and then talk about the other parts. So we're going to define something called run simulation, just like in the bike share. Now it's going to need to know what the system object is and all its parameters, and it's going to need its update function, or the growth function. So once it has the system and once it has the growth function, it can run the steps, which are to create a time series, results equals time series, initialize this first piece of information, so results of t naught are equal to p naught, and then for t in range, oops, wait, sorry, I got carried away. T naught is actually a system parameter, so we need to fix that. So it's not T naught, it's results of system.T naught equals system.P naught. So that's getting that initial parameter into bringing it into the system. And then we need to run our for loop. For t in range of system.T naught to system.Tend, do the following. We're going to calculate the growth. So calculate the net growth at time t. Growth is going to be equal to the growth function where we send into the growth function the current time, the current population, and the system object, so we can send in all those system parameters. That's going to calculate what the growth is. This is that blue function that we were talking about earlier. And then we put in results of t plus 1 is equal to results of t plus the growth. And then lastly, we're going to return results. So by doing what we've done here, this growth function, this is taking the place of this blue part above, and it's going to work for any growth function. All right, so we've passed in that information, and then the system object tells us what t naught is, it tells us what p naught is, it tells us what the end value is, and it also gets passed into the growth function so that it has access to that information. All right, so that's going to be this run simulation function. And why don't I stop now, because let you refresh, and we'll continue in a second.